Hi everyone, it's time for Astronomy Daily again. It's the 21st of April, 2025.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
Hi there, everyone. Hallie here to take you through the show today as my favorite human. Steve is enjoying an Easter break today. So off we go. Straight into the stories I've collected from the Astronomy Daily newsletter. Here we go. Cake, gifts, and a low-key family celebration may be how many senior citizens picture their 70th birthday. But NASA's oldest-serving astronaut Don Pettit became a septuagenarian while hurtling toward Earth in a spacecraft to wrap up a 7-month mission aboard the International Space Station. A Soyuz capsule carrying the American and 2 Russian cosmonauts landed in Kazakhstan on Sunday, the day of Pettit's Milestone birthday. Today at 4:20 a.m. Moscow time, the Soyuz MS-26 landing craft with Alexei Ovchinin, Ivan Vanner and Don Pettit aboard landed near the Kazakh town of Zhezkazgan, Russia's space agency Roscosmos said. Spending 220 days in space, Pettit and his crewmates Ovchinin and Vanner orbited Earth 3,520 times and completed a journey of 93.3 million miles over the course of their mission. It was the 4th spaceflight for Pettit, who has logged more than 18 months in orbit throughout his 29-year career. The trio touched down in a remote area southeast of Kazakhstan after undocking from the space station, just over 3 hours earlier.
You're listening to Astronomy Daily, the podcast with Steve Dunkley.
Following the launch of a classified mission April 20th, the National Reconnaissance Office has reached a new milestone, deploying more than 200 satellites into orbit in just over 2 years. The NROL 145 mission lifted off Sunday on a SpaceX Falcon 9 rocket from Vandenberg Space Force Base in California at 8:29 a.m. Eastern. This marked SpaceX's 10th launch of satellites for the NRO's proliferated architecture, which includes Starshield imaging satellites built by SpaceX and Northrop Grumman. A proliferated architecture refers to the strategy of using numerous smaller satellites rather than fewer large ones, creating networks that are more resilient against potential threats and capable of providing more comprehensive coverage. The National Reconnaissance Office designs and operates classified U.S. government surveillance and intelligence satellites. The agency is deploying an extensive satellite network, designed to track ground targets in near real time. Sunday's launch was the first mission awarded by the U.S. Space Force under the National Security Space Launch Phase 3 Lane 1 program. The task order for NROL 145 was one of 9 awarded to SpaceX in October 2024. This was our first Phase 3 launch, coming only months after establishing this new contract, Colonel Jim Horn, Launch Execution Senior Material Leader at the Space Systems Command, said in a statement. Horn also noted that 44 missions from the previous NSSL Phase 2 contract remain to be launched. The majority of those missions were awarded to United Launch Alliance. ULA's new Vulcan rocket is expected to conduct its first NSSL mission this summer.
Astronomy Daily with Steve and Hallie. Space, space science, and astronomy.
Thank you for joining us for this Monday edition of Astronomy Daily, where we offer just a few stories from the now famous Astronomy Daily newsletter, which you can receive in your email every day, just like Hallie and I do. And to do that, just visit our URL, astronomydaily.io, and place your email address in the slot provided. Just like that, you'll be receiving all the latest news about science, space science, and astronomy from around the world as it's happening. And not only that, you can interact with us by visiting at Astro Daily Pod on X or at our new Facebook page, which is, of course, Astronomy Daily on Facebook. See you there.
You never know exactly when a central supermassive black hole is going to power up and start gobbling matter. Contrary to the popular view that these monsters are constantly devouring nearby stars and gas clouds, it turns out they spend part of their existence dormant and inactive. New observations from the European Space Agency's XMM Newton spacecraft opened a window on the turn-on event for one of these monsters in a distant galaxy. The supermassive black hole at the heart of the galaxy SDSS 1335 plus 0728 has been sleeping quietly for decades. Then, it suddenly lit up in 2019, and astronomers caught the outbursts in both optical and X-ray light. The galaxy, which lies some 300 million light-years away, was experiencing a wake-up call from its central black hole. Astronomers named this newly active galactic nucleus ANSKY. When we first saw ANSKY light up in optical images, we triggered follow-up observations using NASA's Swift X-ray Space Telescope, and we checked archived data from the Arosada X-ray Telescope, but at the time we didn't see any evidence of X-ray emissions, said European Southern Observatory researcher Paula Sanchez-Saiz. She and her team were the first to explore the activity at the black hole. Another team led by Lorena Hernandez Garcia, a researcher at Valparaiso University, Chile, followed up on their work in 2024 by detecting X-ray bursts from the same region. This rare event provides an opportunity for astronomers to observe a black hole's behavior in real time, using X-ray space telescopes XMM Newton and NASA's NICER, Chandra, and Swift. This phenomenon is known as a quasi-periodic eruption, or QPE. These are short-lived flaring events. And this is the first time we have observed such an event in a black hole that seems to be waking up, explained Lorena. What happened to light up ANSKY in a QPE? Think about what happens as a black hole feeds. We know that the extreme gravitational pull of the black hole draws matter in, usually via a spinning accretion disk. It could be a star that wanders too close, for example. The strong gravitational influence of the black hole shreds the star, scattering its material throughout the disk. These are called tidal disruption events. That sounds great until you realize ANSKY doesn't seem to have destroyed a star. There's no observational evidence. However, it has been experiencing recurring bursts of activity, which implies more than one event is occurring. It's possible that a QP could be caused by a star or some other object interacting with the accretion disk but not getting sucked in and creating a different kind of TDE. Researchers went back to the drawing board to consider other possibilities. It could be that the accretion disk isn't formed by a star, but is a result of gas being drawn into the black hole's gravity well. The X-ray flares that the astronomers saw at ANSKY suggest the disk could be experiencing energetic shocks created by the presence of something traveling through it, but not getting disrupted. Something on a headlong rush through an accretion disk would produce multiple events, sort of like a boat cutting through water. Those events would create the X-ray flares. The bursts of X-rays from ANSKY are 10 times longer and 10 times more luminous than what we see from a typical QP, says Johin Chakraborty, a team member and PhD student at the Massachusetts Institute of Technology. To get the X-rays, you need highly energetic events in the disk. Each of these eruptions is releasing 100 times more energy than we have seen elsewhere. ANSKY's eruptions also show the longest cadence ever observed, of about 4.5 days. This pushes our models to their limits and challenges our existing ideas about how these X-ray flashes are being generated.
Roger that, Control. We're listening to Astronomy Daily, the podcast.
NASA's PUNCH, Polarimeter to Unify the Corona and Heliosphere, mission has successfully completed its spacecraft commissioning phase. Last week, the team opened the instrument doors, allowing the spacecraft to capture, first light, its first images of the Sun's outer atmosphere and the surrounding space. These early observations mark a key milestone in the mission's goal to better understand how the Sun's outer atmosphere extends and flows through the solar system. The team will now move into the next stage of commissioning, preparing and fine-tuning the onboard instruments for scientific operations. On April 14, the mission's Narrow Field Imager (NFI) and one of 3 Wide Field Imagers (WFI) were the first to open their doors and begin capturing data. 2 days later, on April 16, the remaining WFIs followed. The first image from the NFI shows a star-filled field with the Sun near the center. To better highlight background stars, the image was processed to reduce the effect of zodiacal light, a faint glow caused by sunlight scattering off dust particles orbiting the Sun. During the rest of the commissioning phase, scientists will calibrate the instruments to reveal finer details of the Sun's corona, its wispy, outermost layer. This process involves removing about 99% of the overwhelming light from the Sun itself, making it possible to trace the delicate, faint streams of solar material as they move through space. The WFI image below, taken April 14, shows the wide field of view from WFI and is marked with labeled constellations. As commissioning progresses, the Punch team will be removing the star fields and other background light from all images to highlight the faint stream of solar wind as it travels toward Earth. These early images confirm a crucial milestone: the cameras on board Punch's 4 satellites are in focus and functioning as designed. The Punch satellites include 1 NFI and 3 WFIs. The NFI is a coronagraph, which blocks out the bright light from the sun to better see details in the sun's corona. The WFIs are heliospheric imagers that view the very faint, outermost portion of the solar corona and the solar wind itself. Once the Punch satellites reach their targeted alignment, the images from these instruments will be stitched together to create the wide view of the journey of the sun's corona and solar wind to Earth. Once the commissioning is complete, Punch will provide the first-ever imagery of the solar wind and coronal mass ejections in polarized light, enabling scientists to discern new information about this activity.
Astronomy Daily, the podcast. Astronomy, space, and science.
And finally, something for Steve to enjoy while he's relaxing by the pool, right, Steve? A story about Mars. Scientists have known for a while that Mars currently lacks a magnetic field, and many blame that for its paltry atmosphere. With no protective shield around the planet, the solar wind was able to strip away much of the gaseous atmosphere over the course of billions of years. But evidence has been mounting that Mars once had a magnetic field. Results from InSight, one of the Red Planet's landers, lend credence to that idea, but they also point to a strange feature: the magnetic field seemed to cover only the southern hemisphere, but not the north. A team from the University of Texas Institute for Geophysics thinks they might know why. In a recent paper, they described how a fully liquid core in Mars could create a lopsided magnetic field like the one seen in InSight's data. The Earth's core isn't completely molten despite what you may have learned in elementary school. There are 2 distinct cores, a solid inner core and a molten outer core. The inner core remains solid due to the immense pressures on the iron and nickel found there. So, the magnetic field that covers our whole planet is, in fact, created only by the outer core. Researchers have long thought that a similar dynamic, solid inner and molten outer core, was present on Mars when it maintained a magnetic field billions of years ago. After about 3.9 billion years, the rocks that formed some of the large impact basins from that time, such as Hellas and Isidis, would contain rocks that would have magnetized while they were cooling due to the presence of the field. Since they don't, there is little evidence for a strong global magnetic field past that point. The going theory was that, as the planet's core cooled, the entire core became solid, eliminating the spinning molten metal that creates the magnetic field in the first place. Fraser discusses the question of when Mars' dynamo shut down. However, there was a strange feature in Mars' magnetic field, a massive difference in strength between the field in the northern and southern hemispheres. This dichotomy was first noticed during the Mars Global Surveyor mission back in 1997, but data from the InSight lander also confirmed a stark difference between the 2 hemispheres. Various explanations have been offered for why the dichotomy existed. These ranged from the effects of large asteroid impacts to very early localized tectonic activity. However, the scientific community has not widely accepted previous explanations. Enter the new theory from Chi Yen of the University of Texas and their co-authors. Theirs is a twofold explanation. First, the red planet could have had a wholly molten core, and second, a massive temperature difference between the northern and southern hemispheres led to the heat escaping only in the southern hemisphere. Magnetic fields can be artificial, as Fraser discusses here. In Mars' case, a molten core would be a primary mover of the process known as a planetary dynamo, which creates planetary-scaled magnetic fields. With a solid inner core like the Earth's, the dynamo effect could have been disrupted by inefficiencies in the system's fluid dynamics. It could also explain how the temperature gradients allow such uneven heat extraction. If the southern hemisphere had much higher thermal conductivity, heat would be more likely to flow through it, causing the churning that creates the planetary dynamo to happen primarily on the southern side of the planet. To prove their point, the authors created a model version of early Mars using a supercomputer at the Maryland Advanced Research Computing Center. They varied the fluid dynamics of Mars as well as the conductivity of its crust. They found that the conditions that most accurately matched the results from InSight and Global Surveyor occurred when Mars' core was wholly molten, and there was a significant difference in the thermal conductivity of the northern and southern hemispheres. Keeping Mars any artificial atmosphere Mars has would require a magnetic field, or something similar. As with all research, there is plenty more left to do. The authors suggest further analysis of some of the seismic data from InSight to see if any additional data was already collected that could align with the molten core theory. Other potential paths forward could include improved modeling for a broader range of internal and external planetary conditions or a deeper understanding of Martian meteorites from various regions and times. For now, this new theory seems to hold water, or molten iron, depending on who you ask. But there is a lot more work that needs to be done to prove this theory and its implications for the existence of life on Mars.
You're listening to Astronomy Daily,
The podcast.
And that's all I have for you today. I've enjoyed flying the studio for you, and I hope you enjoyed the stories I pulled from the Astronomy Daily newsletter files today. I'm sure Steve will be wandering back sometime next Monday if I can find him. See you next time.
Bye.
Astronomy Daily, the podcast, with your host, Steve Dunkley.